I have the power! And we're going to be talking about powers today. No, not magical kind or any of that fictional or weird thing or stuff. Um, but power in mathematics. Not like all of the cool things you can do with it, because you can do a lot of cool things, but power as in the actual term in math that has to do with an exponent. So a power is going to be the number of times you multiply a number by itself. For instance, if I had 2 raised to the first power, that means I would just have 2 sitting there like so. It's there. It's by itself. There's only 1 2 there. Multiplying times nothing. It's just there. So it's 2. But if I add 2 to the second power, then I would have 2 times 2. If I had 2 to the third power, I would have 2 times 2 times 2. And so on and so forth. Notice that each time as the power goes up or the exponent goes up, these words are interchangeable. But as the power goes up, we multiply by an additional number. As power goes down, one of the numbers goes away. Well, actually, it's being divided away. Is another way to think about it. Because division is just inverse of multiplication. You'll see more about division soon. But so that's just an interesting thing to note right now. Because if we do 2 to the fourth, we will just add on another 2. But what would happen if we did 2 to the 0? Because each time we've gone down the power, we've gotten rid of a 2. And at 2 to the first, there's just a 2 there. So that means there would be nothing written here. Nothing's written here. So what does it equal? Oh, it equals 0 then. No. We're talking about multiplication here. So when nothing's written and you're talking about multiplication, there's a 1. Why is that? Well, when we're talking about addition and nothing was written, when we're talking about numbers just being represented by their values, which would come from addition, and nothing's written, it was 0. Why? What happens when you add 0? You get the same thing. No matter what, if you keep adding 0, no matter how many times you add 0, the numbers and the value still remains the same. With multiplication, however, if you multiply by 0, you get 0. No matter how many times you multiply 0, you get 0. The number changes from what it was originally. The value changed from what it was originally. It has now become 0. It's become nothing. So that will not stand here. We can't say 2 times 0 is going to be 2, because that's not true. But if we multiply by 1, it keeps its identity. It keeps its value. Any number times 1 will remain the same. Similar to how any number plus 0, when you add 0, it remains the same. So when we do 2 to the 0 power, in other words, we have no 2's multiplying, it's going to equal 1. Well, wouldn't that be for any number? Yes, it would. Any number 2 to 0 power is 1. The exception to this rule is 0, because, well, if you have nothing and you do it no times, then what is that? I don't know. And no one knows yet. It's undefined. Undefined meaning that it has no definition, meaning that we don't know yet, or we may never know, or maybe it never will be anything. But anyway, that's just like extra math trivia for you. 0 to 0 power, no one knows what that is. But any other number to the 0 power will equal 1 every single time. So whenever you have a power, just remember that is a number of times you will multiply this larger number here at the bottom. Well, they call that the base. So when you have a power, it's important to remember 2 things. Power is the same thing as exponent. So if you see a problem saying raise something to this power, that means, like say, for example, something said take 3 and raise it to the 4th power, that would be 3 with 4 as the exponent. So it's important to remember that. Also, it's important to remember that every time you have this, you have a base raised to a power, or you can call it a base raised to an exponent. and your base is the number that you're going to multiply each time. So if you have a base of 2 and an exponent of 3, that would be 2 times 2 times 2. All right. So I like to think of it as exponents and powers, similar to how when you had addition and you repeated addition, you had multiplication, and when you repeat multiplication, you have exponents. So that's kind of cool how it just continues to build on itself. And with subtraction just being negative addition or inverse of addition, and division just being uh, inverse of multiplication, it's kind of interesting that there is actually something else that would be inverse of a power or an exponent. And, well, we'll talk about that soon. But that is powers. So just remember, you have the power to use powers. I know that's corny, but I'll see you soon.